Hello, I think we're back. There was an internet outage. It was a very odd internet outage, which took a while to clear. Um, I didn't do anything at my end, so these things happen. Yes, I'm back. It's unrelated to the issues that I had a few days ago with my NAS. I just had an internet outage. Call back, call back the search helicopters. Save the CO2. I know. Well, actually, we need to save the oxygen, I think, rather. But a little dangly bit there. Was it? Right. So, hey, you waited around. Look, here we go. I have no idea at this point. I have no idea at this point. No reason to be precise. It's pointless to be precise these days. Apparently. Um, So, where I was at right when the stream died was the point of success in that it's now actually working. As you can see, it has nicely spaced those two guys. And now I'm going to combine this with the percentages. Each of these is going to be 10% of the width. And let's make them 50% of the height. And ta-da! Which is exactly what I wanted. And then you know, we can add a few. It's good. These are containers, but now I support percentage of the parent, and that really makes, I mean, that's kind of like the base functionality that you need for reorganization of things. But we're going to have to do a test for intelligent containers, right? Not just things. Let's do an intelligent container test. The vertical container contains, these are all horizontal containers. I'll make 3 horizontal containers that are all going to be, say, 30% of the width. And with that policy, and those are there, we'll make the height, say, 20%. But these are themselves containers. So each one of these containers could contain another object. So we could try, say, each one of these contain, we'll put a sub node in here, another vertical container. We can see you can do a vertical container, and we can put in here in the geom of this something that says this vertical container inside the horizontal container is going to be again 30% width. Width equals 30%. Height equals 100%. And we could have 3 of them. 1, 2, 3, and save that. And oh, and nothing happened. Okay. I don't know if that just failed to update. We'll try. Oh. Then nothing happened because there was a parse error. The top right window is moving. The window moves. Expected semicolon. Dot identifier. I have some kind of syntax error, and the message was, oh, yeah, we might want to add some semicolons here. That's why it didn't update. So maybe you make this 90%, then you can see it. So we can have, these are vertical ones inside the horizontals, where the the container that can, it says it's 20%. That's right. Let's make it 90%. You get the idea. This is going pretty well. I'm going to make these all 90%, 90%, 90%. Okay. Now, of course, if I have to repeat this, this gets a bit tedious. So what I could do is put a deep node, which is this first one, a horizontal container. And this is going to contain all of this, like so. And then I paste it in here. And now we've got some inheritance going on. Deep node is the equivalent of this. So all I need to do is say deep node. I have an anonymous node. With a bit of luck, I'm going to see if it, yeah, that was too much. Too much difference. The reload on the fly is going to need some work to make it work. But as you can see, what we now have is a horizontal container that's arranged 3 children. And these I actually start off with a vertical container. The vertical container only has one thing in it. Oh no, it has 3 things in it. It looks like it's around. Oh, that's because I changed the default settings here. This is a horizontal because I changed the policy down there. That should be confusing. So what I can do is get rid of these, you see, and now I can repeat that one by inheritance 3 times. That worked with a reload. Those inner ones are vertical components, and the vertical components could contain stuff. I will try putting a light in there, but I'm just going to read the chat. You need a counter for compiling breaks. But thinking about it, I would need to hook the compiler output or the console output to a bot that counts automatically and also the right way. I don't have grandchildren, no, because you have a main container and three children. Oh, well, the project might have grandchildren. I don't. Yeah. So this vertical component is going to have a subcomponent in it again, where we could have a button. So I'm just going to try this this random stuff out. This is going to have a button in it. Now I'm not calling the button anything because I added anonymous nodes, so it will generate the name automatically. because often you're not interested in the name. We'll see if this works. So one of these should have a button in it. And there is a button. The button is very big, and it's in the wrong place, and that's because it's not using the computed coordinates. I think instead of a button, well, let's make the tech. Is it responding? Oh, look at that, it's responding. We'll say the text on this button is going to be blank. That worked. And then we are going to change the size of the button. Width is equal 10, height equals 10. Change the width and height of the button. Maybe I should call this H. Try again. So this button is a small, tiny button. And we can afford to make it a bit bigger than that. And this is my little button. Oh, an error when I clicked on it, because I haven't hooked it up to anything, but don't worry about that at the moment. So I have my little button, but now I need to make sure that my little button is drawing correctly. So I'll go to UI button, and I can fix this in a jiffy. Because the problem is that in my draw function, it is accessing the wrong things. I need it to access CX and CY and CW, the calculated geometry. And that's all good. But anywhere else where it does this, CX, CY. Yeah. Should do the trick. Now hopefully we will have our little button in the right place, or alternatively nowhere. The nowhere is not quite what I was looking for. That's a little bit disappointing. Put a breakpoint here. It should be there. The problem is that the width and the calculated width and height of this is 0. Oh, it's still important to calculate its own thing. And it had calculated width and height. It had calculated X and Y on courtesy of its parent, because the parent placed it, but it hadn't calculated its own width and height. Non-containers need to still deal with their geometry, and I'll need to add that in a minute. But we have a new person on the chat. What's the? This is Dennis. I'll call you Denny if that's okay. I mean, I could call you DD, but that has been used as a kind of nickname for me. I don't really like it. It's not a problem. I'll call you Denny. Yeah. Ah, welcome. I am working on a GUI. Yes, indeed. DDE. I could call you DDE. It's only 3 syllables, I suppose. DDE. Yes, I'm working on. I'm working on a game engine experimentally for educational purposes and to test out some theories about engine design. But I'm taking the slow route, which means I'm doing it probably in the reverse order that people would normally do an engine. I don't know. You can build an engine. It seems very often people start with the graphics and they might try to create a spinning cube. I've done spinning cubes before. They're really not very interesting. What I do know is that in any game engine that you use to build a game, there are points of pain. One of them is the UI. They're difficult to work with, and you can have tooling that generates your UI, which is then totally displaced. The data for that is complicatedly hooked up to any code, and I feel there's a better way, and it's a way I've used. I first used it in the end of the 90s on a PlayStation 1 game. That particular technique, and it's what I'm presenting here. I came up with the idea of was that, yeah, it was, what was I doing? I was actually experimenting with OpenGL at home, and I came up with the idea. And the idea is to have a file with hierarchical. You could think of it as a hierarchical ini file. We have nodes inside of nodes and so on. That in itself isn't anything particularly special, but what this one has is inheritance. And if you add inheritance, it's amazing how powerful the thing becomes. And since I needed for something that I wanted to build, which I might pause this and go back to Phi. It's why the project's called Phi 2. It's an idea of creating a microcontroller based on the Phi computer architecture, as represented in the Phi programming language. And I want to make an FPGA of this thing so I can invent a microchip that doesn't have a clock, a microcontroller that doesn't have a clock, but you program it with instructions. Yeah. So I started doing that, but then I needed a UI for it, so I got SFML, and then I just was going, I could throw this together and have some buttons that you press and some lights which would be connected to the microcontroller, but it felt like, not fun and annoying. I said, if only I had my UI system, I could knock this up in moments. And so then it was, I could try making that property tree thing again. And then it was, I could try making that property tree thing in C++20, because then I will learn C++20, which I have never used before. Before I started work on this. Never had reason to go to 20. And so then it was, might as well build an engine then, and that's where we are. Well, it's all software rendered or open. At the moment, I'm using SFML, so it's which is a 2D library. So I'm not, at the moment, I am building an engine from scratch. We'll see how far it gets. For research purposes, if you were making a game for real, you probably wouldn't do it this way, but that's not what I'm doing. I'm not making a game. I'm making a game engine to study how to do that with my latest theories on the best way to go about constructing an engine in C++20. But so right now you're seeing SFML, because that's the other point, I suppose, is if you want to build a game engine, you don't have to all the way through refuse to use any other technology that's out there. You can intend to replace the renderer later. So you could build your game engine starting off with Unreal. If you've got Unreal with the source code, then seriously, you could build your own engine using Unreal as the actual renderer. And why would you want to do that? Well, if you do that, it means you can get going on a bunch of stuff. And for me, the most interesting stuff is not, to be honest, the rendering part, although I really would dearly love to dive in some more, because I've only dived into, hardcore graphics programming only a little bit. And so I really, so it's not I don't want to do that. But the really interesting parts of a game engine are not the renderer. It's an important part, and for performance reasons, it's an interesting part. Trying to from an engineering point of view, it's fascinating and all that. But from a game development point of view, far more of a problem are our workflows and stability and fast iteration. And our engines that we have available to us these days don't always deliver, in fact very commonly don't deliver on the fast iteration front. So I'm looking at that, and I think I could turn this into a 2D engine that people could actually use. Is very much within reach. That's not a huge amount of work. I would get there relatively quickly. If I wanted to make an engine that had full support for everything you get in Unity and Unreal, see me in about 10 years. So it's, yeah. But anyway, that's the story. So I'm using SFML at the moment, but what I'm working on is obviously something that could be applied anywhere. I could actually make a plugin for this for Unreal, which would be interesting. ImGUI is excellent. I have used that, and I could have used ImGUI, and I've used ImGUI to solve interesting tooling problems within Unreal. So I've used ImGUI with Unreal. I highly recommend it. But this being a hobby project, I'm trying to not use other frameworks, because the problem there is that I'm exploring the architecture of a video game. If I use ImGUI, that is already architected, and I wanted to do my own for the reasons I've already said as well. So but ImGUI is very good. You're an electronic student. Well, if you like, send me an email. You can see I've got a couple of email addresses there. If you send an email to tech@igneous-ent.com, the thing is, maybe we could collaborate, because I have a really interesting idea with regards to how this could work. And it's a matter of creating a microprocessor on an FPGA that works according to the Phi programming language. And if you're interested in what the Phi programming language is, that's Fi, check on YouTube and look for Phi programming language and my name, and you should come up with a video that has it. There's a small channel, it only has a couple of videos on it about the Phi programming language, but it includes a demonstration of the first demo of the Phi programming language from a prototype interpreter, which I wrote a couple of years back or more. And I wrote that project until I could demonstrate the concept, and then I stopped at that point. So, but the basic idea with it is that you can create computer programs with a language that doesn't have a program counter and doesn't have a clock. In fact, the CPU doesn't have a clock because the language doesn't have a program counter. It's a fundamentally different architecture for constructing a computer from a Turing machine. And if I was still, if I'd had this thought, like, 40 years ago, 30 years ago, I would have gone for doing a PhD on this topic. But I didn't have the idea then, and the idea has taken ages to sort of develop. But the point about it is that a Turing machine, a representation of a Turing machine, has a head on an infinite length of tape. In effect, that head, with its position on the tape, is the program counter. When you look at, a microprocessor, it has the next instruction it is executing, at least on each core, and that has a program counter pointing to some kind of memory, virtualized or not virtualized, whatever. If the point is, it's like a point on this tape, and it will move forward and back and then change the contents of the tape. And this is what the construction of a Turing machine is very directly related to what a CPU does. But the theoretical that I want to make physical Phi microprocessor uses a completely different concept that doesn't have a program counter. And as such, it's perhaps a superset of a Turing machine. Like the Turing machine is a specialization of this because you can create a Turing machine in it. So if any of that interests you, send me an email and we can talk about it. And, I don't have an infinite amount of time left. Resources are limited. And if I found somebody to collaborate on the FPGA side of things, that would be fantastic. And if you're looking for a project to work on, that could be a good one. The email, yeah, you can send me, it's on the screen. So you send it to tech@igneous-ent.com. Okay, and that will get to me. And then by using those, I don't have to give out my personal email. So yeah, send me an email, tech@igneous-ent.com, and yeah, that would be really great. I love to work with people, so yeah, if that's of interest, we can explore it. I promise you, if this works, it's going to be exciting because it's like going back in time to when the computer was being envisaged. Go back to Turing and then later von Neumann, and you can see how everything has grown from what came before. But I have this theory that there was a point early on in the development of the computer where it may have been impractical. This point, why it didn't happen, is it could have been impractical. But now that it might be practical, you imagine going back to this point where there was a different way of looking at computers that could potentially have resulted in solutions to all the major remaining issues that we have in computer science. Because I think that would, because my argument is that it is the existence of the program counter that is the fundamental problem. Even I mean, I'm going out of my area of expertise a bit here, but even the halting problem. Is it possible, I wonder, that if you go to a superset of a computer that isn't a Turing machine, which I believe what I'm talking about is, the question then is there a solution to the halting problem up there? Because the proof that the halting problem can't be solved relies on the Turing machine. And everybody talks about languages being Turing complete. And maybe there's this other thing. So anyway, I'll stop selling it at this point. I'm just going to catch up with the chat. Yeah. I wish I mean, to be honest, I wish I had gone into electrical engineering when I was instead of computer science. I think I would have. Well, and if I had done that, I probably wouldn't have made Kickoff. I'm often saying that making that game ruined my life, and it's probably an exaggeration and probably a bit unfair, but sometimes it's that thing. I could have been something else. I could have been an electrical engineer. Well, there you go. Building an abstraction of Unreal is a very good project because Unreal sometimes is a bit wacky for pure 2D games. Yes, that's it. Question is about licensing. Well, the way that I would do that, but right, just for licensing, and it is another way of making this kind of research into something that's actually fruitful in an external way. I mean, it's fruitful anyway for me, but fruitful in the kind of sense somebody else looks at it and goes, "Ooh, I'd like a piece of that." Is that you make an engine that connects to an engine. It's a meta engine, and in a sense, Nugget is a meta philosophy. It's a meta architecture, and that's where the Nugget comes from. It's a name I gave to a particular architectural framework, but the philosophy behind it is that you can just swap anything out. So a meta 2D game engine is that's a good idea too. So what that would be is you make your game engine in an engine that hooks on to Unity or hooks on to Unreal. Could be a plugin in either. And so the licensing is not a problem because there's not anything that says you can't do that. Unity are not going to chase somebody down because they make a plugin that uses an alternative way of constructing a game. For example, using the Phi programming language in order to do things that you can then connect it to any engine. And this is the philosophy we desperately need. I really think we desperately need this, because then you can create. You can imagine how you could create any video game in any framework to operate in any other framework, but you develop it in a very lightweight engine, which is another thing to think about. I'm building an engine. What does that even mean? It isn't, it could be a prototyping engine. It's where you sort out your gameplay and you hook it up to a very lightweight system that starts up immediately. It doesn't have, it's not bloated in the same way as the engines that we have, but you can construct your game in that. And then when you're ready, you hook it up to a proper game engine. And we need more of that kind of thinking. I desperately believe this. It's sort of built in, isn't it? People think about a game engine, where I'm kind of thinking it shouldn't be that way. It's not a game engine, So yes, and I like what you're thinking, because maybe that's a really good thing to do. Build your game in a little framework that's so lightweight and easy to use, and I think this can be done for 2D games, definitely. Lightweight, easy to use, it's fast, you iterate stupidly quickly, and you can connect it to any game engine. Gosh, that excites me. Because that's what I want. I think if I had that, and maybe that's a motivator here, if I had that, I think I would be inclined to experiment more on making games. You've seen me making games. I mean, I was a few years ago. I was making some JavaScript games. But because I was experimenting. But if you're not being paid to do it, it's a question of you do it for fun. And so often, at a certain point, it ceases to be fun anymore. When the thing reaches a certain size, it becomes a little less fun. It kind of would be great if you could keep the fun going for longer. I don't know what I'm saying anymore. But anyway, here we go. Please make it open source. Maybe we can have a C++ competitor to Godot. So like I'm saying, I don't see it as a competitor potentially. I think, I mean, really thinking about it as I'm talking over everybody's comments, it feels like there's something that is within reach. And I'd be happy to do open source, but I'm not going to do open source before I have people who want to participate. Just the thought of having an open source project hanging there that is just, it's like a drain on the soul if nobody's really interested. But if people are interested, I'm happy to do that. Sorry, I'm way behind on the chat. A synchronous machine, yes, it is. It is asynchronous in the sense it doesn't have a clock. Please keep us on stream in the loop of how this with the microchip is going on. I work on digital twins. This could be a very interesting use case for our research at work. Or send me an email as well, Merlin. Because one of the things I would love to see happen is to make something happen with this idea of the Phi architecture. Because I mean, it's that thing. I think that it can solve a huge number of problems that we have in software and computing. I see potential of this that is just far reaching, and I don't have anywhere to go with it. So I will. And I think we're at a certain point when I've done enough of developing this, so it's mature enough that then it can be tinkered on and worked on and so on. I'll probably jump back to reason I did this originally and create the UI for the simulation of the microcontroller. Memory segmentation is, yes. And to be honest, in the Phi architecture, the big problem is memory because of the way that it works, which is on transitions. So it's necessary to generate events upon the change of data. And but then, that's the thing, is that you can imagine how if way back in the past we had started thinking about how to solve that, we would have solutions. And I think there are solutions. It's a different way of constructing a computer to the way that we do. So typically consultant, he know when to stop talking because my mouth is already full of water for this delicious piece of tech you were talking about. I never know. I never know when to stop talking. I never know that. I talk too much. Ask anybody, you know. Um, I'm a talker. I think I need to develop my skill of when to know. As you can see, you said that, and I carried on talking. So there you go. I just love how players handling creating games is very. It's Temple OS. Oh, Temple OS. I really. I never dived into the architecture, but I do know about the story of Temple OS, and it's a sad story. But you're saying that maybe it's worth revisiting that. The guys from Frost Giant Studios decided to build their own game engine from Stormgate because all engines on the market were performance-wise very bad for a modern AAA RTS game. So I agree, sometimes writing your own engine is a very smart thing to do. I would recommend, though, that if somebody is considering writing their own engine, it's they do it when they know what they need from it precisely. So if I was argument for me, I could have written my own engine for Kickoff Revival, is I knew exactly what I needed from the engine. 1 second, I'll be right back. Sorry about that. So yeah, I mean that would have been totally doable. And one of the advantages you get with writing your own engine, if you are very clear on what you need, is that you will get better performance. You know, I mean, especially if what you need is a subset of what a full game engine can provide. Because you will be able to tailor the whole architecture to that specific thing that you are doing, instead of using a technology that needs to sort of serve general purpose stuff. So that's a thing, you know. When people ask me about, you know, making their own engine, I think we've got ourselves so boxed into the idea that if you want to make a game, the first thing you do is choose an engine. I think if you want to make a game, the first thing you do is you look at the technical requirements and you consider all possibilities and how best to build it, which sometimes could be, depending on the details of the game, making your own engine. So it's a much more nuanced question than just, you know, what do you think of people developers who make their own game engine. I mean, it depends, you know. So I agree. We need good documentation for an open source project. I would maybe participate in this if I find the time. Oh, that'd be great. I think bit of a long way to go yet for that one. Was Fraunhofer IPK Berlin? That's where you. Oh, you work at Fraunhofer. I'm not sure if we are the right research institute for this idea, but it sounds very challenging. I think Fraunhofer, they do a lot of research stuff, don't they? But yeah. 21. Wait, you were talking about the Temple OS with the biblical. His Temple OS is younger than you. Is Are we talking about the same Temple OS? Oh dear. Well, I think I would. Yeah. Well, let's see. We can always talk about it, and I love the idea of collaborating with people. Now, the thing about Temple OS is, I just want to check now because you guys confused me. Are you talking about? I can't remember when the guy. In my mind, it's old. It was by Terry A. Davis. It looks like he passed away in 2018. So there we go. Okay. Well, we got this thing sorted out. I think it's as interesting as a sad story, and I think the really sad part about it is that it was probably. Oh, well, I won't say. It's like it's just sad. Anyway, you can. What is what? What's that about? A not grey skin color. You can set virtual machine and all it's all open source. There's no static libraries or DLL. All right. Anyway, let's see where we're at. So, what I'm trying to do now is I was going to try and put something in one of these containers. That was the button. The button didn't appear. The button has vanished. The button interruption. I'm used to getting interrupted. What was I doing? It's like, yeah, the problem was that the button didn't have its computed coordinates set, because the only things that are setting their computed coordinates at the moment are containers, and this is a button, not a container. And in order to fix that, I need to make it update its own container values, whatever, which I can do in update geom properties, which is defined here, which pulls in these, and interestingly it fetches the CX, Y, whatever, but it shouldn't. It should compute them. Yeah, I mean, when I update the specifications of the geometry of a component, it really should be updating the computable ones. This change here might affect what I've got so far. So I'm thinking that what I need to do there is a, where am I right now? UI imp. There is a thing, isn't there, that I said calculate self size and calculate self pos. So I think I'm going to give this a go. We'll see if it works. Calculate self size and calculate self pos are both necessary here, but not this. This is wrong. No, and even that is not wrong. It's a little more complicated than that. Because when I calculate these, it puts them back into the property tree, and then I need to read them back out of the property tree. Perhaps not ideal for performance, but and yeah, we need to do an identifier and an axis for both of these as well. So it's a little bit complicated, because I need to do calc self size for GID or ID, it's ID 0, and then ID 1. Surely, why are you complaining, compiler? What have I done wrong? What's wrong with that? Expected a, really? Oh, yes. Yes, I'm trying to put code inside an initializer. Oh, how clever is that? Answer, not very clever. What I could do is this instead. Calculate ID, 0, ID, 1. So what's happening is I'm calculating the self size in both axes and the position both axes. Those are calculating the computed things, and they're doing it from, from what? Yes, they are actually already reading these. There's an argument I don't really need these anymore if they've been calculated, but I can optimize later. It's a bit ugly for efficiency, but it should work. It should be robust. I calculate the new CX, CY, CW, CH, but I'm also reading these values in. Where it's inefficient is that this is already reading these, and then they get read again. I think I might put a to do here. To do. This is wasteful. But I will live with that. when you read the Wikipedia, your screen was entirely white, so your webcam brightened up the entire video feed, which led your skin to be lighter as well than usual. Over here, I have very pink skin, and then it gets progressively whiter as it gets to the screen. No, it's fine. Don't worry about typos. Oh. No. Well, I did all of that. Did it work? No. That's a little disappointing, as I really hoped that that would work. I think what I need to do is I can do this, and I can trace it. So my button is trying to configure itself. I jump into update Geom properties, and then the key exists, and I'm calculating the self size. And there are no dimensions to the units, and the size is 20. Oh, I'm being foolish. Look at what it does. It returns the value. Come on. Right. It's very inefficient, but we'll go with it. I worry about optimization now. I'm distracting myself from the thinking, which is the structure. I'm thinking about the structure of the code. It's two separate things, and it's difficult to do both at the same time. I think actually unwise to try to do both at the same time. So, because you could end up until you've sorted out the structure of the code, you don't know for sure that it's the right idea that you're on. And then you've wasted time optimizing something that you then have to throw away. You know, the optimizing work is just thrown away. That's the nature of optimization. Optimization is based around a functionality that you need, and then you find shortcuts because of that specific case. So it's it's almost impossible for optimization work to ever be savable if you have to modify your code in a significant way. So therefore, it is better to be inefficient in the early part and make sure you nail the structure of your code before you do the optimization. I can't understand that. It's completely, look at this. Got these little squares here, which makes no sense at all. And that happened when I tried to modify this. And calculate self size. Well, I have them reversed for a start. This is the That's not good. The position is CX and CY, and the thing is CW, CH. That would create some degree of nonsense. Okay, now that is also wrong. Okay. Have a good night, Merlin. Take care. Thanks for tuning in. If I take this out and I try to run it, do I fix everything and break except the button? Right, that's back to where it was. The problem is putting it there is a bad idea. So what we could do is say I'm going to try this void. Kind of need a specialist function. UI entity base imp configure self. Or self geom. That has this in it. I spotted an error here. No, I didn't. It's fine. Entity base imp. I need to create that in here. Okay, DDE. So, right, let's see if that builds. Good night. Thanks for tuning in. Consider configure self geom is not a member. I think I put it in the wrong place, didn't I? Yes. That should be here. Configure self geom. And right, let's see what this does. Okay, that's fine. And what I need to do is to the button, we need to do configure self geom. Yeah, please do. Hey, worked. So now I have a button in each one. And I can add another button in the other vertical containers. So this is working extremely well. Was not able to handle that change. Oh, you sent me. Oh, you sent. Okay. Let me check. I thought you were saying you will send an email. Let me see. Well, the emails from that address can take a little bit to get to me, so let me see. I can pull the emails out. Do that now. I can ask it to update. Yeah. Check email now. Last check 37 minutes ago. I received an email. Doesn't look like I got it. How annoying. When I last tested it, it worked. Oh. Yeah, I think I did, but I think you ended up in my. Did you just say hello? If you just said hello, I got it. I don't want to say what your real name is. Yes, 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 I did get it. It went into my spam folder. Excellent, I got it. And I just replied. Having a problem with the send. Yeah, you should get an email now. Okay. I have my magnifier off. So we now have a series of buttons. You didn't get it? I just sent it via Gmail. Maybe you need to check your spam folder. Okay, cool. All right. So when I'm looking at this, I can see that this is not highlighting when I hover over those buttons, and that's probably due to not getting the computed coordinates. Is position hovering? Yeah, it's calculating not to the computed coordinates. We can use email to figure that out. I mean, we can chat on. We could have a call if you like, but let's start with email and we'll figure it out from there. Oh, right. These are not. Yeah, that's better. Hopefully that will now. The hovering. Yeah, the hovering now works. I could make here a deep button, which is derived from button and is the same as button, except that the text is blank and the size is a bit bigger, like 50 by 50. Then in here we can simply say deep button. And deep button. So you can see how this works. It's quite nice. Like this, the deep button, it just follows the definition of deep button. Derived from button. Yeah, maybe we could have a talk. We could have a chat first of all, and then I can fill you in a little more. And I have some code for the simulation that I've already done. I can describe to you the general idea of what needs to be done, and it involves having memory that is able to detect changes and trigger things to happen when memory addresses change. So yeah, let's have a chat, and then if you're interested in the project, we can take it from there, right? I think it would be awesome to have a microcontroller. Yeah. Oh, just send me an email, or I'll send you an email how we can communicate. You know, either probably Google Meet is probably a good one. So I will send you an email with that when I finish the stream. Okay. And then I can add more deep buttons here. This is on a vertical container. Will a reload work with this? Oh, I didn't think it would. That's too much. too much. And now we have all of these. We have a whole load of buttons in a whole set of containers, and that is, I'm very happy with that. But there's another milestone achieved. Wow, look at that optical illusion. You see that? If you stare at that pattern, it looks like they're kind of nodes in the corners between where there are 4 orange boxes. When you look at them directly, it goes away, but then from your periphery, it looks like these. Yeah, weird. Right, we'll have a chat and we'll see if you know, there's a collaboration opportunity. So I'm thinking here, this is pretty good. If I turn on the text, let's put a letter A. It coped with that. You see, because of the power of inheritance. Oh, this is another optical illusion. I don't know if it's doing this to you, but if you look at, say, the A that's in the middle, that's great. But the other A's seem to be getting distorted and leaning a little bit to one side or the other. So maybe it would be good if I had a way of it's really weird, that, isn't it? If there's a way of changing the size of the text, that would be a good thing to do. So I'll do that next. Button code. You're beginning to see the power of the system, right? Because that was making a change to a single node. Make them all B. And we'll need to look at the size of the font. So we can set font with character size 50. So I'm going to just add a nice little thing to the button so we can see how, I mean, this is now adding a facility for changing or specifying the, my word, they do change shape. That's it. Change their lean. So what we can do is add to the button a facility for specifying the size of the text. There we go. This is the base class for the button. We don't have anything for the text size yet. But I'm going to put in the text size of, say, 20. And I can do that, and it's the rectangle disappeared because it's been overwritten by the text font. Although interestingly, it didn't disappear. Okay, it disappeared because of a bug, probably to do with updating. Okay, right, there's a bug. If I reload the file, it's not properly resetting the frame of the button. That will be that issue, right? So adding the character size, it should be as simple as notice get int. I'm just using int 64s at the moment. ID r ID comma and text color. Oh, that extra comma. And that didn't work. What's wrong? Conversion from int 64 to an unsigned int. Conversion to the data type of SFML. Now we have a problem, and let's have a look at the stack trace. It's probably right there. It didn't find that node because it's not text color, text size. Let's try again. And now I can change the size of my A's. I go to the point here where I had the text. I said the text is A. I can say the text size is now 100. Right. Text size is now 5. Text size is now 10. Let's reload it properly and we get the little buttons back. So of course from this you can see you can set up anything. I mean, it's not the prettiest of UIs at this point, but that's because I'm just building things out of the most simple drawing elements. But you know, you could then set it to have a background color, a frame color, rounded corners, drop shadow, a texture, a gradient, whatever you want. And then it doesn't take that much work for this to become quite a good UI. You need a certain number of things to make a UI work. And if you don't have those, it doesn't matter. You know, there's nothing you can do. You don't have enough basic API calls for doing your UI. There won't be any way around it. So I need to add some more APIs. I won't be able to create it in C. Well, I don't know. I mean, I think I was thinking about the FPGA side of things, but we'll have a talk. I mean, the idea is to build is to put it onto an FPGA so that we can actually then build a physical microcontroller with this architecture. So great. What do I want to do next? It's a good question. I've got my reorganizing stuff. Got some bugs to fix. I think I could actually start looking at something else now, though. I mean, I don't need to make my UIs look pretty at this stage. Maybe have a UI to create. Yeah. Cases like you'd have to have something to create. It makes it a bit easier than trying to make test cases. So I could use as a test case. Maybe we're ready. Are we ready to go back to the Phi project and actually make this what would be a very simple little UI? So we have text. Oh. Labels. I could use some labels. But I think I'm going to do that on a different stream because I'm pretty tired. And I think this is a good place to leave it with should we see the connection lines? Well, these lines are just, you're seeing the container outlines. And yeah, for now, just for debugging purposes. But great to meet you, DDE. And yeah, thanks for the chat. It was great fun. And I'm going to leave it there for now. Oh, for FPGA. You need to use Verilog for that. Is the best bet. And that you use that language to create your FPGAs. All right. So thanks everybody for watching. And take care, everybody. And I'll see you again soon with the next installment of the experimental Don't Try This at Home C++ 20 engine. Take care. Bye.